All right, so welcome. This is going to be the video for section 421. How can I solve inequalities? This is going to be the day one of this section. So in this case, again, we've been talking about how to solve these different kind of equations now. Now we're going to kind of ramp it up to put it together with inequalities. So some of you remember inequalities probably back from eighth grade maybe. Some of you probably did it in Algebra 1. In this case, they're going to come back kind of with a lot of different forms in Algebra 2 as well. So we've been talking about, again, how to solve them with an equal sign and look at them on a graph and then looking at them just in terms of their solutions with using algebra. And now we're going to, again, put it to test here with this. So in problem 458, it said in the previous section, you learned how to use the graph of a system to solve an equation. How can the graphs of y equals 2x squared plus 5x minus 3 and y equals x squared plus 4x plus 3, this is in your packet, help you solve your inequality? Consider the question. So I went ahead and put it on the back of here as well. In this case, again, if you want to do that, please by all means feel free to. If not, otherwise you can just go ahead and make sure that you can do it in your packet as well. So it says, consider fun equations. How are the solutions 2x squared plus 5x minus 3 equal to x squared plus 4x plus 3 represented on this graph? Well, folks, if we remember, when we set stuff equal to each other, again, our biggest focus is we're trying to look for, again, the solutions where they intersect. So as you can see, we have different intersection points within the graph. So when they cross over one another, we know that they are, again, equal, because in this case, again, whatever x value we plug in, we're going to get the same y value. So in this case, we plug in the value -3 here, we're going to get out the output of 0 for both of those functions. And the same thing up here. In this case, when we plug in, I think that's the value 2, we'll get out the value 15. So we're going to go ahead and put that to the test. And here's how we're going to do it. In this case, to answer the question though, how are the solutions 2x squared plus 5x minus 3 equal to x squared plus 4x 3 or plus 4x plus 3 are represented in this graph? In this case, they intersect. They intersect, and that is where their solution is. So what we're going to go ahead and do is we're going to go ahead and solve this for this function. In this case, again, it shouldn't take us too long. We've kind of been practicing with these a lot now. So in this case, I'm going to go ahead and kind of put this all together. So therefore, I'm going to go ahead and do 2x squared plus 5x minus 3 and set it equal to the value of x squared plus 4x plus 3. All right, so the nice thing about this is we can go ahead and kind of plug these in and therefore set them equal. So therefore, I'm going to go ahead and subtract x squared on both sides because I want to go ahead and put my terms together. I'm also going to subtract 4x as well. And then I'm going to have that positive here and subtract 3 on that side. So as you can see, what we're going to end up equaling to that right side is we're going to end up equaling the value of 0. The reason why I subtracted that x squared term is because I want to keep this positive 2x squared term, again, positive. Because in this case, again, when we go ahead and, as you probably guess, we're going to factor this. In this case, again, it'll be a lot easier to simplify. So therefore, anything I do on the right side, it'll cancel out. I'm going to do on my left side as well. So therefore, subtract x squared, subtract the value 4x, and then subtract the value of -3. So as you can see, what ends up happening is we're going to end up getting some new terms. So therefore, put a 1 underneath and do 2x squared minus x squared, which gives me x squared. I'm going to have the value of 5x minus 4x, which gives me positive x. And then I'm going to have the value of -3 minus 3, which gives me -6. So now you have x squared plus x minus 6 equal to 0. So now you're going to go ahead and factor out your solutions. So in this case, to get them, all you got to do is remember two numbers that multiply -6 and add to 1. So therefore, these values should be, in this case, the values of x plus 3 and x minus 2. And they're going to equal it to 0. And then using that same kind of idea, zero product property, in this case, I'm going to go ahead and plug these in. I'm going to do x plus 3 equal to 0. And I'm going to do x minus 2 equal to 0 in the solved form. So therefore, I get the value of, as you can guess, x equals -3, and then x equals the value of 2. All right, so now, as you can see, what this ends up working is we end up having these two solution bases here, and that's the story of our problem. So in this case, again, where do we intersect? And then again, if you want the y value, you just plug them in to the x value to get them out. So either one will give you the same one there. Now, for letter C, what it's asking us to do here is says on a graph paper in your packet, identify the x values for which 2x squared plus 5x minus 3 is less than or equal to x squared plus 4x plus 3. And how did you locate the solutions and how many are there? So in this case, if you want to figure out a solution that can work for both of these, in other words, what you would have to do is you just have to kind of test a point. So as you can see, what we end up having here is we end up having those 2 points that we end up having for -3 and 2. So what I'm going to do is I'm going to go ahead and try to identify the x values that could work here. So if I look at the x values, I'm going to go ahead and back and look at the 421A here. I'm going to try to see the solutions that would actually work for this inequality. In other words, to make it true. So in this case, what I end up having is I end up having the values that I can simplify for each of them. So I'm going to go ahead and just try a value. So on the bottom here, you probably noticed a number line, and that is for good reason, because in this case, what we're going to do is we're going to go ahead and try to simplify these for the solutions that can work for the inequality itself. So in this case, what we're going to do is we're going to go ahead and we're going to go ahead and try to test a point. So the point that I always test, especially with inequalities, to make it really easy for yourself, is the value of 0. So when I plug in 0, it makes all the terms usually cancel out, and then you're left with just a few constants here to simplify. So what I'm going to do is I'm going to go ahead and plug this in. I'm going to go 2 times 0, quantity squared, plus 5 times 0, minus 3, is less than or equal to, and then the value of 0 squared, plus 4 times 0, and then plus the value of 3. So now what I'm going to notice is I'm going to end up getting an inequality in terms of the solution base. So therefore, 2 times 0 squared gives me 0, plus 5 times 0 gives me 0, and then minus 3, which in this case is just going to give me -3. And then if I look to the other side, my right side, or the greater than or equal to side, I'm going to have 0 squared plus 4 times 0, which gives me 0, plus 3. In this case, there's your solution. So in other words, -3 has to be less than or equal to 3. In this case, again, if you remember your inequalities, you always eat the bigger number, so therefore that one checks out. So in other words, if we look at the number line over here, what we end up noticing, or in this case on the graph, the x value, whatever it is for us, that solution actually works. So in this case, if I look where x is 0, so in this case right here, the value for it ends up becoming true. So therefore, if I had a point, in this case, if I plugged in that value of 0, what I ended up noticing is I ended up getting the output. So therefore, when I plug them in each side length, what I can do is I can go ahead and shade them. So what I'm going to do is I'm going to go ahead and plug this in. And then as you can see, I got my y value outputs -3 and 3. So therefore, if I look here for this equation, what I end up noticing is I end up having that function of 2x squared plus 5x minus 3, which in this case, if we have that 2x squared plus 5x minus 3, that's going to be the value that in this case is shifted 3 to the right. So therefore, this is this function right here. I can kind of draw it in a little bit more. Should be this, should be this one right here. My apologies. So this is the 2x squared plus 5x minus 3. So in this case, again, that output when we plugged it in for 0, we got 0, -3. So if I look to my solution here, what I end up noticing is, again, any value between that 0 and -3 actually works as a solution. So in this case, what we end up having is we end up having a solution that falls in this part here. So in this case, anything that is less than, or excuse me, greater than the value for the solution for inequality. So in this case, anything up here as well. Okay. And then what we're going to do is we're going to go ahead and take a look for overlap. So in this case, that overlap, we're going to go ahead and consult the other problem, which in this case, if we look, was 0, or excuse me, x squared plus 4x plus 3. So therefore, as you can see, we got our solution there, which was 0, 3. So I'll go ahead and look back, and therefore then you have that y is equal to x squared plus 4x plus 3. And as you can see, I have a different pen color, so therefore I'm going to shade this one a little bit differently. So we got one that looks like this. So in this case, our solution lies at the point 0, 3. So if I look here, in this case, the 0, 3 is the value that kind of lies right here. So in other words, the solution is anywhere that's below this line here. So therefore, I can go ahead and kind of shade this as I see fit. Okay, so now it kind of looks like a big jumbled mess, but what we're looking for is we're looking for the actual solution for the problem. So if I look inside here, I'm looking for where they actually overlap. So if I shade really, really hard, you can actually end up seeing where the purple and the blue actually overlap. So in other words, what we end up having is we end up having a solution. So anything in between this right here is going to actually count as a solution. So the wonderful part about this is, again, this problem, when you shade, and then you're able to kind of see the different colors kind of overlap, and then you're able to kind of see your solution. So that's why I always tell students they have 2 different colors. So it asks on the graph paper, how did you locate the solution for them? Well, in this case, again, you looked at the problem that we did when we plugged it in. So when we plug it in, we're able to again see where the solution actually checks out. We can check if that inequality actually does work. So in this case, how many are there? Well, there's going to be a lot of different ones. In this case, again, how many solutions are there? Well, with whole numbers, there's only so many. But in this case, again, if you use decimals and such, there can be infinite amounts in this case. Okay, so infinite amounts within the solution. All right, so we're going to go ahead and kind of now apply this to the idea of a number line. So some of you, again, have seen number lines recently. Some of you may have not. What we're going to do is we're going to go ahead and kind of put this on a number line and mark our solutions where the solutions would be within the same color. So we actually already solved for where the boundary points are. In this case, we ended up actually solving for them here and here. So in this case, -3 and +2. So when we solved them, we weren't just solving for where they are at the x-intercept. We're actually solving for where the intersection points. We're actually solving for where they're on the boundary points as well. So in this case, what I'm going to go ahead and do is I'm going to go ahead and take a look at this problem here. So therefore, we have the 2x squared plus 5x minus 3 is less than or equal to x squared plus 4x plus 3. So now what I'm going to go ahead and do is I'm going to go ahead and plug this in terms of your solution. So therefore, first one I solved for was the value of, in this case, -3. I'm going to go ahead and put a -3. And then the other one was the value of 2. All right, so now here's the big kicker with these, especially students struggle with this often. If the sign has an equal to underneath, so in this case, less than or equal to or greater than or equal to, what you're going to end up doing is you're going to end up filling in those circles. So in this case, that's going to tell us we're going to include those 2 different solutions there for our point. Now, in this case, when we did the problem for 0, in this case, we tested it back over here. What we ended up seeing when we tested the value of 0, we ended up getting those solutions, and we ended up seeing that that statement's true. So the nice thing about this is we actually already solved for it. So therefore, when we solved for it, we ended up getting the value, in this case, the solution for 0 that worked. So therefore, what we can do is we can actually shade in the middle for our solution there. So in this case, again, you can go ahead and do so. Now, if we wanted to write the inequality for that, in this case, or if the solution's in the same color, what would that inequality be here? Well, in this case, the solution would be any value, or in this case, x. Okay, and then if I go back here, any value that would be less than or equal to the value of 2, and it has to be greater than the value of -3. Now, you can write it like this, or what you can do is you can actually write it as one inequality as well. So in other words, our solution looks something like this. Okay, so the wonderful thing about inequalities, again, the solution, in this case, again, we can actually have multiple solutions represented within the integers and the whole numbers here. Okay, so as you can see, we just kind of test it, and then we kind of go from there and try to solve for it as well. All right, so if you want to go ahead and practice, go ahead and stop this video. They give you another example here, just in terms of 2x squared plus 5x minus 3, and then x squared plus 4x plus 3. But now what we're going to notice is we have a different inequality sign. So therefore, no longer is it less than or equal to, but now it is greater than or equal to if I'm reading it left to right. Now, the nice thing about this is the boundary points didn't change. In this case, again, our solution is still the same for those boundary points, but now at those boundary points, what we're going to end up having is we're going to end up having open dots. The reason why is because no longer do we have the equal sign. In this case, again, we just have the greater than sign. So therefore, what I'm going to do is I'm going to go ahead and test my solution by plugging in the value of 0 again. So in this case, if you remember, we plugged in 0 for the last problem. So I'm going to just do it over here just to make it a little bit easier for us to see. But I'm going to go ahead and plug this in. And I'm going to go ahead and do 0 squared plus 4 times 0 plus the value of 3. All right, so now you got this whole thing again. Obviously, it cancels, and you're left with just the constants. Negative 3 is greater than 3. Now, some of you are looking at that and now saying, well, the last one, that was true, because in this case, negative 3 is less than or equal to the value of 3. But now, when we flipped it around, in this case, negative 3 is greater than 3. We know, obviously, that is not true. So therefore, what we end up having is we end up having a solution that's no longer at the value of 0. So in this case, any value, in this case, tested on the inside here, so like a negative 2, a negative 1, or a 1, those wouldn't work in our solution. So what we need to do is we need to go ahead and shade on the outside here. So in this case, the solution is going to be on the outside on here. So therefore, if we want to write the solution to that inequality, in this case now we're dealing with a little bit different flavor here. In this case, now we're talking about two different things that are kind of happening. So in this case, we're less than that value of negative 3, and we're actually greater than that value of 2. So in this case, our solution for this problem, any x value that's going to be less than negative 3, or any x value that is greater than 2. And I'm sorry, I should put that equal sign in there. I should have just had that less than. So therefore, our solution looks something like this. Now, with this, as you can see, we have a bunch of different kinds of problems that we look at when we solve. So solving inequalities, again, isn't too much different than actually solving an equation. The only other thing you got to do is you just got to make sure that you fill it in on the number line, or sometimes you got to fill it out on the coordinate plane to kind of simplify for your solutions. So I'm going to break this down into 3 easy steps for you when solving inequalities. So that way, again, you can kind of find your solution. So the first thing, step 1, is to actually solve the inequality. And you can actually change the inequality to an equal sign. The reason why I always tell students to change it to an equal sign is because we're very familiar with changing them into equal sign. And it's easier to solve simply because in this case, sometimes the inequality actually, when we solve for them, will actually flip. You may remember actually when you divide by negative, the solution actually does flip when you do so. In this case, again, you got to make sure you're cognizant of that, and we'll practice with those kinds of problems later. But in this case, I always tell them solve the inequality, again, whether it's an absolute value or whether it's a square root function, and then again, change the inequality to an equal sign so you can solve it. Now, once you get that, step 2 is, in this case, you found your boundary points. So your boundary points, again, are those points that you would solve for when you get the equation. And then you're going to go ahead and test your solution. Now, testing your solution usually means like a check, or in this case, when we have an equal sign. When you test your solution, you're trying to figure out where the inequality actually has for, in terms of you're actually going to shade. So in this case, you're going to find your boundary points and test your solution. I always tell students to use 0. The reason why, again, 0 is the easiest to simplify, and once you do, you're able to, again, kind of simplify for the other terms and do so there. So again, nice and easy, not too much work. All right, and then the last thing that you got to do is make sure that you, again, write your inequality. I'll write out your inequality, which again is your solution, and shade appropriate values. Okay, so in other words, again, the last part, what we did here, as you can see, we kind of shaded it in, use the open dots for the boundary points, and then you can solve for the other part. So also I should add open or close dot for the boundary points. Again, students get that confused a lot. And again, it's something that is kind of minor sometimes, but it can make a whole lot of difference for the problem. So solving the inequality, you're going to solve for, again, the inequality, change the inequality into an equal sign, find the boundary points, test your solution, use the value 0, and then write out the inequality and shade the appropriate values. Now, we're going to go ahead and put these 3 steps to practice. So on the back side of your paper, in this case, you end up having a problem. It says consider the inequality. In this case, 4 and then multiplied by the absolute value, of x plus 1 minus 2 is greater than the value 6. So in this case, it's going to ask us how many boundary points are there, and then the boundary point is the smallest number that will make the inequality not true. So what we're going to go ahead and do is we're going to put those 3 steps to practice. So as you can see, I have a number line. I'm going to go ahead and solve. So first step, solve for it like it would be a normal equation. So I'm going to go ahead and do 4, and the absolute value of x plus 1, and then minus 2. But now, instead of writing the inequality, which is greater than 6, I'm going to go ahead and get rid of it. I'm just going to ignore it for right now. I'm going to write equals to 6. Reason why is because it's a lot easier, again, to solve. So therefore, first thing I'm going to do with solving the absolute value, I'm going to go ahead and get rid of that negative 2 there. I'm going to do the opposite and undo it by adding 2. So I'm going to have 4, and then the absolute value of x plus 1 is equal to the value of 8. So I'm going to go ahead and solve that there. Next thing I'm going to do is I'm going to go ahead and divide by the value of 4. So in this case, again, everything's being multiplied by 4. I'm going to divide by 4 on both sides. So I get the absolute value of x plus 1 is equal to the value of 2. So now, this is where the absolute value gets a little bit different, because in this case, when we are talking the distance from 0, in this case, we're both talking about the positive values and the negative values. So what I'm going to go ahead and do is I'm going to split them up. So in other words, x plus 1 is going to equal the value of the distance from 2 to 0. So one of them, obviously, is going to be the distance of 2, because in this case, again, 2 has a distance of 2 from 0. And then the other one, in this case, is the opposite value of it. So in this case, negative 2. Now, what we end up having then is a very one-step problem to solve. So therefore, I'm going to subtract 1 on both sides, and I'm going to get the value of x is equal to the value of positive 1. And then the x value is going to equal the value of negative 3. So these folks are what we call our boundary points. So in this case, again, the boundary points are the ones that, again, are the smallest value that actually make the inequality true. So therefore, I'm going to go ahead and plug these into my number line. So therefore, again, I'm going to go ahead and label. In this case, again, we have the greater than sign. So therefore, they're going to be open dots. So therefore, I'm going to go ahead and take a look. I'm going to kind of label it. I'm probably going to go like negative 3, and then negative 2, 1, 0, 1, 2, 3. So that's good enough for me. And in this case, I've got my open dot at negative 3. And then I'm going to go ahead and have my open dot at the value of 1. All right, so that was step 2. So in this case, again, step 2, telling me that I'm going to go ahead and find the boundary points, which I did, and then test your solution. So now what we're going to do is we're going to go ahead and test that solution by plugging in a value. Again, the one I always choose is the value of 0. The reason why is it makes everything so much easier. Now, what I'm going to do is I'm going to use that inequality now in this form to make sure that, again, it is true in terms of what the inequality is saying. So I'm going to do 4, and then the absolute value of 0 plus 1, and then minus 2 is greater than 6. So as you can see, what ends up happening is we end up now checking our solution to make sure it does, in fact, work. So we're going to go ahead and do it. 0 plus 1, that gives us the value of 1. The absolute value of 1 is 1, but in this case, what I need to do is I need to also multiply by 4. So therefore, I'm going to have 4 minus 2 is greater than 6. And if we keep simplifying, 4 minus 2 gives us 2. 2 is greater than 6. Hopefully you're figuring out, obviously, this is a no, because in this case, again, that is not true. So in other words, the value of 0 does not work as a solution. So that means that the solution doesn't actually lie on the inside, In this case, what the solution does, it is actually lies on the outside. So therefore, I'm going to go ahead and shade on both sides to get that value. So this is step 3. So I'm, again, shading that solution now to where it will lie in terms of the inequality. So therefore, my solution in the last step is to go ahead and write it. So therefore, I'm going to write x is less than any value of -3, or the x value has to be greater than any value of 1. So here's your solution. All right, so as you can see, 3-step process. First step, again, solving for that inequality just like you would an equation. So therefore, again, getting your boundary points. Once you get those boundary points, you plot them on there, and then you go ahead and check your solution to make sure that, again, you know where to shade. So in this case, I always test the value of 0 because, again, that's usually the easiest one to simplify. And when we do, we end up getting an inequality that, again, tells us if it is true or not, and it tells us, again, where we shade. So therefore, we get that -3 or x is greater than 1. All right, so this is section 421. Again, this is talking about the inequalities. So this is kind of the last step in terms of chapter 4. So you're going to be kind of solving these now for the rest of the chapter. We don't have too much time before the end of the semester, so make sure, again, that you're asking questions as needed, especially for the chapter 4 test, because, again, a lot of you are right on the cusp of grades and such. So make sure, again, that you're doing everything that you can to be successful. All right, I'll be back on Monday of next week, January 7th. So please let me know if you have any questions. Otherwise, have a great weekend, and we will see you all on Monday.